The third out of the 4 different linear equations that you're going to be asked to draw the line is the third one, that is y equal mx plus b. This equation is also known as the slope-intercept form. And here's an example of this type of equation. Graph the line represented by the equation y equal negative 3x plus 1. I hope you notice that this equation looks very similar to y equal mx plus b. They match. Now, how do you graph this line? The same basic idea. You need 2 points to at least draw the line. Don't forget that every point has an x and a y coordinate. Now, what is different in this equation, different than the first two that I already explained, is that in this equation, there's no specific value for the x, like I did in the first equation, or no specific y value, like I did in the second type of equation in this video. So what do? Well, we need to look for the implicit information that is stated in this equation, y equal mx plus b, or y equal negative 3x plus 1. And what is this equation implicitly saying? That the value of y depends on the value of x. So if you can find an x, you can figure out how to calculate the y value. That's what basically this equation is implicitly stating. The value of y depends on the value of x. So basically what I'm going to do is I'm going to choose value of x, any value for x, so I can calculate the value of y that match with that value of x. So for example, I usually use 0. So I'm going to use 0 for x the first time. And you're wondering why I gave the value of x 0, because the value of y depends on the x. So I have to start somewhere, and I decided to choose the value of x to be 0. So I can figure out now the y that match with that x. And I figure out my first point. So how do I figure out the value of y of my first point when the x is 0? I'm going to take that value of x, 0, and I'm going to replace the x in the equation with 0. And I get this. The parentheses that you see here is the x. I replace the x with 0. I plug in 0 for the x. Don't forget to follow order of operation when you work it out. You can see that the value of y is going to be 1. And look, I got my first point. Let's do the same process for my second point. I don't have any value of x. I don't have any value of y. So choose a value for x, any number, as long as it's not the same one as 0 that we already chose. And once you know the value of x, once you use a specific value for x, you can calculate y. So let me see. I'm going to choose -1. And I want to find out the value of y when the x is -1. So what I'm going to do with that -1 for the x, I'm going to replace it in the equation wherever I see the x. So the parentheses is the x. I plug in x with -1. Follow order of operation. So you can simplify this expression, numerical expression, and you get 4. Look, I have my 2 points. Now I'm ready to draw the line. Don't forget that these points sometimes are set up in table format as a table of values. And we're ready to plot the points. 0, 1, start in the center and at the origin. No left, no right, stay there. And then from there we go 1 up. Every time you have a point on the y-axis, we call that the y-intercept. Let's plot the second point, -1, 4. Start at the origin. Go 1 to the left. And then from there, go 4 up. Wherever you land, put the second point. The moment you have 2 points, you can connect it with a straight line. I hope you notice this line is different than the first line I made with the first linear equation. That was a vertical line. This line is not vertical. It's also different than the second line I made with the second type of linear equation. That was horizontal. This line is not horizontal. How do we call this line? We call it slanted lines, inclined lines. So every time you see an equation that looks like y equal mx plus b, you're going to be drawing a slanted line.